Welcome back, students. Please take the next couple of minutes using your book, not Google, as a resource to define the following terms. You're going to want to pause your screen to complete your bell work at this time. All right, everyone. So the first part of this chapter, it just has a lot of vocabulary, so we're going to go through this pretty fast. We're going to start by talking about sampling and data. Statistics deals with the collection, analysis, interpretation, and presentation of data. We use this in our everyday lives. There are two different subcategories of statistics, which are descriptive statistics and inferential statistics. So in the first part of statistics course, we're going to be dealing with mostly descriptive statistics. Descriptive statistics is organizing and summarizing data, and this is basically going to be through using graphs and numbers. For example, finding an average, which you guys use all the time probably in your everyday lives, such as using averages to calculate your grade point average, or using averages to calculate what you need on a test to get an A in a course or a B in a course or pass the course. All of those types of things are considered descriptive statistics. After we've discovered the ways in which we can organize and summarize data, we can go ahead and use inferential statistics, which is the process of drawing conclusions from the good data. And this method of statistics uses more formal methods, and it allows us to look at data and find the significance and therefore draw conclusions to make future predictions on data. Statistical inference uses probability to determine how confident we are that our conclusions are correct. Probability is a mathematical tool that we can use we skipped a few slides. Probability is a tool that we can use to study randomness. It deals with the chance or the likelihood of an event occurring. So some examples of this are, if we flip a coin, what are the chances that it will land on heads, and what are the chances of it landing on tails? And we would get 50% that it will land on heads in one flip, if it's a fair coin, and 50% chance of getting tails on one flip on one coin. But what we're going to do is take this further. How about if we want 5 heads in a row? What's the probability of us getting 5 heads in a row, or 10 heads in a row, or 5 heads and 5 tails? So these are all ways in which we will learn throughout the semester to analyze data. Another example would be, what is the probability of drawing a face cards out of a deck of cards? Well, you have 52 cards in a deck. How many of those are face cards? Then you would use that to determine the probability of getting a face card with one draw. But then we can take this further and discover what is the probability of getting a face card, and that face card is a heart. So these are the types of methods we're going to focus on for the first part of our statistics course. For statistics, we generally want to study a sample of a population. You can think of a population of the collections of things, persons, or objects that we are focusing on for study. To study the population, we collect a sample of a population. The idea of sampling is to select a portion or a subset of a larger population and study that portion to gain information about the population. And this data results from sampling a population. That's how we get data points. We sample a population, we gather the data, and we can then analyze the data to make conclusions from that data. From this sample data that we just said, we collected a sample of a population, we can calculate a statistic. A statistic is a number that represents a property of the sample. So when you're taking a statistic of a portion of the population, it just is a number or a quality that represents the population. The statistic is an estimate of a population parameter. A parameter is a number that is a property of the population. So the parameter is basically saying what is going to make this subset eligible to be within our population. The accuracy of our data really depends on how well we sample the population and how well does that sample represent the population. The sample must contain the characteristics of the population in order to be a representative sample. We are interested in both the sample statistic and the population parameter in inferential statistics. I left you guys a little example here in italics. For example, if we consider one math class to be a sample of the population of all math classes, then the average number of points earned by a student in that one math class at the end of the term is an example of a statistic. Data are the result of sampling from a population like we spoke of, and because it takes a lot of time and money to examine an entire population, sampling is a very practical technique. Instead of using the whole group of the United States, we can use a subgroup of randomly selected people in the United States to get a pretty accurate sample size that can be representative of the entire United States. Now, we will learn further in this course that there are specific things you want to consider when you're taking a random sample of a population. One of the main concerns in the field of statistics is how accurately a statistic estimates a parameter. So if our parameter is the United States citizens, well, how accurately did our random sampling actually represent the sample of the entire population of the United States? Did we think about the demographics of people? Did we think about their age distribution? Did we think about where they live, their socioeconomic status? Because to actually get an accurate sample, we want to make sure that this is an accurate representation of our larger portion, the United States, when we have just done a randomized sample. We really want to have accuracy in that parameter that we have set. A variable is usually seen as X or Y, is a characteristic of interest for each person or thing in a population. Variables may be numerical or categorical. Numerical variables take on values with equal units such as weight in pounds and times in hours. Other examples that we can compare to the numerical variables to categorical variables is by saying an A, B, C, D, or F letter grade. While those are typically categorical variables by saying A, B, C, D, F, we can also value that numerically by saying an A is equal to 90 to 100%, a B is equal to 80 to 89%, whereas categorically speaking, A, B, C, D, or F are categorical variables where it places the person or thing into a category. So all of those who received A's or all of those who received B's. While those aren't numerical variables, we can also think about them numerically as well. Sometimes that is not possible for every type of categorical variable that we will speak about in this class. Mean and average are both the same word, and you can use them interchangeably. Mean is basically going to take the proportion of the population to see how much of the population got a specific average of whatever data point you're thinking about. So you can also think of average and mean as interchangeable concepts. If you guys want to pause the screen and try to go over this example independently, I would highly encourage it. And if you would want me to check your answers, please feel free to post in Ask Your Instructor discussion board to get your answers to this question checked. We are next moving into section 1.2, data sampling and variation in data and sampling. Qualitative data are the result of categorizing or describing attributes of a population. Qualitative, it's talking about qualities. We're not talking about numbers here. Here we're talking about hair color. There's no number for hair color. Blood type, right? There's no number for blood type. Ethnic groups, the car a person drives, and the street a person lives on are all examples of qualitative data. Qualitative data are generally described by words or letters, right? We're not talking numbers here. We're talking about qualities that describe a person. Quantitative data are always numbers. Quantitative data are the results of counting or measuring attributes of a population. For example, the amount of money, that's a dollar, that's a numerical amount. Your beats per minute or your pulse rate, that's a number, you can count it. How many beats in 1 minute? Weight, that's a number, you can measure it. Number of people living in your town, right? That's a number. There's a specific number associated with that. So that's the difference between qualitative and quantitative data. There are two ways to describe quantitative data. Quantitative, I always remember, is quantity. That's a number. So we need to remember quantitative is numbers that we're speaking of. And of our quantitative, it can either be discrete or continuous. And we're not talking discrete as being a secret, and we're not talking as continuous in the way that you typically would talk about continuous. So make sure you take notes specifically on this slide, as I don't think it's as easy as you might believe. So data that are the result of counting are called quantitative discrete data. These data take on only certain numerical values. For example, how many calls did you get on Friday? I got 2 calls on Friday, right? We can count the number of calls that you got on Friday. How many calls did you get on Saturday? Well, I had 3 calls on Saturday. You can count how many calls you got on Saturday. Sunday, I got 4 calls, right? That's 4 calls that you can count. These are all examples of quantitative discrete data. When you are looking at examples of quantitative discrete data, you will commonly see this referred to as the number of blank, right? The number of calls you received on Friday was 2. The number of calls you received on Saturday was 3. And this is how we can describe quantitative discrete data. Now we're on to quantitative continuous data. Assuming that we can measure it accurately, it's all of the data that are the results of measuring. So if you're measuring the shoe size of your classmates, right, well, you can have infinitely many variabilities of shoe size. And the numbers are infinite. So it's, for example, height or weight, right? We're not going to count height. We're not going to count weight. This number is various, and like I said, it can be infinite number of many answers to the quantitative continuous data set. Here are some data examples. I want you guys to kind of read through these, pause it, and try to practice. As we don't always have homework in this course, sometimes it might be helpful for you to pause the recording in order to try to practice some of these example questions. For this one, I'm just going to go through it with you so that we can kind of review some of these concepts we've just spoken about. So example 1.5 is continuous or discrete data. Now it gives you the answer in the last sentence, hint, hint. The data are the number of books students carry in their backpacks. Remember, if it's asking you to count something, we are typically talking about discrete data sets. These are quantitative discrete data. We can count the number of books that someone carries. Example 1.6, the data are weights of backpacks with books in them. Can you count the weights of backpacks? No. Can we predict this? Potentially, if we had great data sets and we're able to understand this data, but we're not talking about predicting. Right now, we're just trying to say, is this continuous or discrete? And for this one, it's going to be continuous data, specifically quantitative continuous data, because you can measure my backpack weight, and very likely, if you measured the weight of your own backpack, you would get a different answer. And that gives us infinitely many solutions to this question. So that's what makes it a continuous data set. Example 1.8, the data are the colors of backpacks. Again, we're talking about a quality of our data set. So this is qualitative data. This is not a number that we're talking of. This is talking about a physical property of the backpacks. That's what makes it qualitative data. You can pause your screen if you want to go ahead and practice some more on this type of data collection and methods and definitions, and it will be extremely helpful to you to continue practicing these example questions that are embedded in the slideshow presentation. If you don't want to answer it right now, the slideshows are also embedded into your course Unit 1 under Resources. All right, and for today, this is the last part of our lecture. Please stay tuned for our exit ticket, which is coming shortly. All right, here's your exit ticket for today, Tuesday, February 7th. Please go ahead and pause your screen so you guys can finish up this exit ticket for the day. Record this on your daily exit tickets and be ready to submit at the end of the week. Have a wonderful rest of your day, and I will see you guys tomorrow.